here I'm going to go quickly because I don't want to teach you a lot of C++, but you should know how C++ works. For example, you can define a function of A and B that does whatever. And then in the main program, right, you can just declare two variables, X and Y. You can assign the value 4 to X and 5 to Y. And then you can call that function, F, with X and Y. So these are the arguments, right? And this is the function. And here you have a print statement, right? And so in JavaScript, in C++, you do a standard output stream, cout, less than, less than. Don't worry about it if you've never seen it, but this is a print statement. So it will print this string, followed by the value of X, followed by a white space, and a Y, and then this is a new line character. So don't look at this at the other stuff. Look at this function. It's a regular function, and look at this function call right here. Who can tell me the output of X and Y after you come back from that function call? So X is 4, X is 5. Then you call F, or F by value. Notice this function is a regular function, so it's just called by value. So I put that in the name so you remember that. When you call a function by value and you assign values here to the parameters, what happens in the main program? What gets printed here? X and Y. This is like in Java or JavaScript, so don't worry too much. Just give the obvious answer.
Shouldn't it just be 4 and 5?
Exactly. In other words, whatever you assign to A and B here don't affect anything about X and Y. Why? No pun intended. Because this is called call by value. When you're passing in the X and the Y, you're not passing in literally the variable X and the variable Y. You're passing the value of X and the value of Y. This is why it's called innermost, because you're evaluating the X first, then the Y, before you evaluate the whole function call, right? Call by value. Well, it's in the name here, so I'm not going to write it down. So that means the A and the B here have nothing to do with the X and the Y. These are local variables to the function. When you assign value to those local variables, these variables disappear when you return from the function, so the X and the Y have not been modified. And so this prints 4 and 5. Everybody understand the call by value? This is a good old function in C, C++, Java, JavaScript, and so on. They're just done by value, so this is applicative order. That's the same as call by value, which you need to understand that. So what if you wanted to pass this thing by normal order? Forget about call by reference. I know that Demetrius mentioned that. This is applicative order is still, so call by reference is not the same as normal order. We'll get to see what it is after the break. But there is a way to do normal order in C++ is to define what's called a macro. So some of you have never seen macros. I'm going to give you a 2-minute overview of a macro. To define a macro, instead of using this keyword, the void and whatever, you just use a pound define. Then you give the name of the macro, just like a function. Then you give the arguments. And then you give the body of the macro beside. So it looks like a function, except you have to use that special syntax. Pound define, the name of the macro, the argument, and the body. And also, as an extra thing, which I don't want to explain right now, we'll talk about this later, you have to put parentheses around the parameters when they appear in the body. But don't worry about that. Doesn't affect anything here. So this is the same body, right? B gets assigned to A, and 6 gets assigned to B. It's exactly the same function as this one, except it's declared as a macro in C++. And so a macro uses normal order in C++. So what does that even mean? Remember we said, what would that even mean? So now we have the same setup where we have an X and a Y, the same ones. But now we're going to call this function in normal order. So we're going to call it, in fact, we're going to call the macro instead. We're still passing X and Y, but now we're doing it in normal order. So what does that mean? Remember, normal order means you evaluate the entire expression before you evaluate the X and the Y inside of it. What does that even mean? What that means is you're going to have to do a substitution first. And that's exactly what macros do in C++. So again, if you've never seen macros before, let me introduce you to them today, and then we'll talk about them a lot again after the break. So here's what happens in C++ when you have a call by macro like this. This entire line here, so the compiler, there's a preprocessor. that will take this line and it will replace it by something else. So before this code is executed, there's a preprocessor in C++ that will take this line and will replace it by this. This will be replaced with what? Well, there's going to be two substitutions going on. First, the parameters, or sorry, the arguments x and y are going to be not evaluated because that's normal order. They're going to be replaced or substituted into the body of the function, which means this a will be literally replaced by an x. And then in the macro here, the b will be replaced by the y. This b will be replaced by the y, and this 6 will stay the same. So there is substitution number 1. The arguments, the x and the y, are substituted into the parameters in the body of the function of the macro. So what that means is you take this body and the a becomes an x and the b becomes a y everywhere. That's substitution number 1. And then substitution number 2, the result of step 1, this one, is substituted into the function call itself. So what that means is whatever you got by the first substitution, this block, will get here and will replace this function call. So this box here, this function call, will be replaced by the body of the macro after you do the substitution number 1. So really, this becomes this. Okay, so again, that's just a quick introduction to macros. But to summarize, whenever you have a macro call in C++, this doesn't exist. Well, let's not worry about just do C++. That doesn't exist in Java or JavaScript, right? What it does is say, I'm not gonna evaluate the x and the y. I'm gonna take the string x unevaluated and I'm gonna substitute it into, for every time I see a here, I'm gonna take the string y and I'm gonna substitute it for b everywhere in here. Substitution number 1. And then whatever I got for that substitution, this whole block, I'm going to come in here and I'm going to replace that method call, that macro call, with that block. And so when the body is when this gets executed at the end, this is gone. It's replaced by this. So what happens? Well, now this x will actually modify this x, and this y will be this one. So guess what? When you run this, you actually don't get the same answer, right? So x was 4, but here x is assigned the value of b, which is 5. And then y here is assigned 6. So here you're going to get a different answer. So this is a case where using call by value and call by normal order, or sorry, applicative order versus, you don't get the same result, right? So now we are not in functional languages anymore. So in other words, the Church-Rosser theorem doesn't apply anymore because we use 2 different strategies for the same function and we get a different result. But remember, we are not in the lambda calculus anymore. So the Church-Rosser theorem does not apply anymore. So we didn't break the theorem, right? The theorem only applies in the lambda calculus. So it's okay if we get different results. Anyway, so why do we get different results? Because now we're not in functional programming anymore. We're doing assignment statements. So lambda calculus does not allow assignment statements. So that's why we can't apply the theorem. But to summarize, and time is up, so these concepts of applicative order and normal order, even though they come from the lambda calculus, they apply to every programming language you use every day. In fact, in C++, you have both. And in JavaScript, you have both as well. You're using applicative order almost all the time. But when you're using the ternary operator, right, in JavaScript, it also uses kind of a normal order because it doesn't evaluate all of the arguments first. All right, I'll let you go. Are there any questions on this? This is really the main point for today, those 2 reduction strategies, or how you evaluate function calls.
Yeah, I have a question. So unless you're in like functional programming, is it even possible to have like pure functions using normal order?
Wait, you're saying in functional programming languages?
Yeah,
What's your question again?
so my question is, if you when you're not in pure functional programming, is it impossible to create a pure function using normal order because there's always those assignment statements and stuff like that?
Oh, I see. So yes and no. I see. That's a good question. So it is okay. You can write a pure function in JavaScript. So the answer is no, you can write a pure function in JavaScript, right? By using a function with no assignments. And we've done many of those in the assignment. So you can write a pure function in JavaScript. However, because JavaScript uses applicative order by default for all the function calls, you cannot use normal order on these functions because you don't control the compiler, right? So you're right, you can write functional pure functions in JavaScript, but unfortunately, JavaScript will always use applicative order for those function calls because that's what the compiler does. So if you want to use normal order, it has to be built into your language, like in Haskell. But in JavaScript, yeah, you can't really choose because it's built into what the compiler does, so you can't override it. So does that make sense that you can write functional style, you can write uh, pure functions, but you can't force it to be executed in normal order, unfortunately. That's a very good
Oh,
question. Anybody
uh,
else? The same way that you can't force JavaScript to evaluate this in applicative order, right? This is normal order no matter what, because that's the way the compiler works. So you don't have that flexibility. But in Java, in C++, you could choose. That's why you have those two options. You get macros or functions. So you get to choose which one you use. But in most languages, you don't get to choose. Good point. Anybody else? Okay, so this is kind of important. Review that for Wednesday, and then we'll keep moving on with the Lambda calculus on Wednesday. So just remember, even though it looks like a small language, it's very powerful. In fact, it's as powerful as any other language. And second, all these definitions that we do, like leftmost, innermost, and so on, and leftmost, outermost, they apply to every other programming language. This is why we study them in the Lambda calculus, because Lambda calculus is so simple, it's so pure, that you can demonstrate all of these concepts in a simple language with no assignments, nothing like that. And then you can make sure you understand what they mean in your favorite programming language.